Swayam Prabha. Digital India. Educated India.
So, welcome back to the course on analytics. In this lecture, I would like to discuss the correlations. Correlation, specifically product movement correlation. Further, phi correlation and Spearman's rank correlation coefficient would be discussed. This is a quick section to just have an overview of product movement correlation. Product movement correlation, that is small r, this is noted by small r, that summarizes the strength of association between two metric variables. Association between two metric variables. Metric means it could be either interval or ratio scale. So, say the variables are x and y. So, it is an index that is used to determine whether a linear or straight line relationship exists between x and y, and it was originally proposed by Carl Pearson. So, this coefficient r is also known as Carl Pearson correlation coefficient. So, it is also referred as simple correlation. Simple correlation or bivariate correlation. Because two variables are related here. So, from a sample of n observations of x and y, the product movement correlation or Carl Pearson correlation can be calculated using this relation. R is equal to summation the difference of xi to x bar and the difference of yi to y bar over sum of squares for xi and sum of squares for yi. So, these all I are from 1 to n. So, if we see this, if we divide both of these by degrees of freedom by n minus 1, divide this by n minus 1, we can see that the relation in the numerator is covariance of x y, and the relation in the numerator is the standard deviation for x and standard deviation for y, if I take this into the under root. So, r is nothing but covariance of x y over standard deviation for x and standard deviation for y. R varies between minus 1 to plus 1. Plus 1 between means perfect positive correlation, minus 1 means perfect negative correlation. The correlation coefficient between two variables will be the same regardless of their underlying units of measurement. Correlation does not change. Correlation does not change with the units of measurement. Also, it does not tell the reason. It does not tell the reason that why there is a positive correlation or negative correlation. It just tells that yes, it is varying positively. Let me take an example for this. So, we have the respondent numbers here. There are 12 respondents. Attitude towards city is scaled here, and duration of residence in the city is given. Importance attached to weather is given. There are 3 variables and n is equal to 12 here. So, what do we do? So, let us try to find the correlation between the attitude towards the city and duration of residence. Let me put this as y variable and this as x variable. So, first we will calculate x bar and y bar. Here y bar comes down to, that is calculated here, x bar is average of all the values here, y bar is average of all the values here. So, this x bar is sum divided by 12. So, this comes down to 9.33, y bar is 6.583. We can calculate xi minus x bar into yi minus y bar in this way: 10 minus x bar into 6 minus y bar, 12 minus x bar into 9 minus y bar. So, this whole calculation is done here and this value comes down to 179. Similarly, we calculate xi minus x bar square for all the observations, yi minus yr square, and we calculate this r. So, these calculations are taken from the book Marketing Research by N.K. Malhotra. You can refer the book for more details. So, this is very simple correlation. So, what is the value? The value is coming 0.93, which means the correlation is very strong. If I divide the correlation from -1 to +1, 0 here in between, if I divide this, correlation 0 means no correlation, -1 means perfect negative correlation, +1 is perfect positive correlation, and if I divide this further, 0.5 minus 0.5, if this is more than 0.75, they say that this is strong positive. So, this exhibits strong positive correlation. Types of correlations: this is positive correlation and linear strong positive correlation. This is negative correlation. You can see that by increasing value of x here, the y is decreasing. At this value of x, y is large. At the larger value of x, y is small. So, this is a negative correlation. So, in the previous example, we can say the correlation is strong. That means we can say that the attitude towards city is very highly correlated with the duration of residence. The length of residence or the duration of residence, the longer the resident has stayed in the city, the positive he has the attitude toward the city. So, he is quite loyal or quite loving toward his city. So, this is no correlation R0. This is again R0. There is increasing and decreasing correlation. These are called non-linear correlation. So, this is a drawback or pitfall of the correlation. There is a relation increasing then decreasing, but the correlation coefficient says I do not know if there exists some relation or not. So, this is not explained by the correlation coefficient. So, for this we need to fit some regression model here. So, before talking more about correlation, I would like to discuss the t distribution. If random variable x is normally distributed, then the following statistic has t distribution with n minus 1 degrees of freedom, where t is calculated as x bar, that is for sample, minus population mean by standard deviation for the sample. So, t is calculated as x bar, that is for sample, minus mu, that is for population, by standard deviation. Because it is for sample, we have divided this by under root n. So, very similar to the standardized normal distribution, the t distribution behaves. It has more area in tails and less in the center than the standardized normal distribution. We will see the t distribution here. This is t distribution. So, these are the value at minus 1.98, deviate value we have 0.25 area on the left hand side and 0.25% of area on the right hand side. So, the confidence interval here is 95%. The degrees of freedom n minus 1 are directly related to the sample size n. The degrees of freedom minus 1 is here because we know one statistic, one of the parameter is known. As the sample size and degrees of freedom increase, S becomes a better estimate and the t distribution gradually approaches the standardized normal distribution for large sample size until the two are virtually identical. We find that the critical values of t for the appropriate degrees of freedom from the table of t distribution. So, if sample size is generally less than 30, we apply t distribution. If it is greater than 30, it is normal distribution. So, this approaches normal distribution. In some cases, some researchers say that this value should be 120 and greater than 120 is exactly normal distribution. So, if we want 95% confidence interval with degrees of freedom 99, then we can find the appropriate value of t from the following table. So, at 95% confidence interval, as we just saw at 95% confidence interval with two tail test here, the area is distributed 2.5% on this side, 2.5% on this side and 95% is here. So, at 95% for two tail test, this is the value. So, degrees of freedom here are 99. This is the value of t statistic here. So, decomposition of total variation. When the product movement correlation is computed for a population rather than a sample, it is denoted by the letter rho, the green letter rho here. The coefficient r is an estimator of rho then. The statistical significance of the relationship between two variables measured by using r can be conveniently tested. So, let us make the hypothesis here. H naught, which is null hypothesis, that implies no relationship between x and y. So, this says that null hypothesis rejected, that is no relationship hypothesis is rejected. So, the test statistic is evaluated using this relation T is equal to R into n minus 2 by 1 minus R square under root, which has T distribution with n minus 2 degrees of freedom. So, we calculate the value of T here. 0.93 was the correlation coefficient value which we calculated here, 0.9361, and the other values we put here, 12 minus 2, so on. So, the T statistic value is 8.414, and for the 10 degrees of freedom, from the T distribution table, the critical value of the two-tailed test for 95% confidence interval is 2.228. Hence, the critical value is way less than 2.228 is less than 8.414. Hence, the null hypothesis of no relationship between x and y is rejected. That means there exists a relationship. So, this is one of the application of the T distribution here. So, there is a non-linear relationship, as we discussed before here. Here is a non-linear relationship. There is a relationship, but the correlation coefficient is 0. So, this diagram is again explaining that thing. So, next is partial correlation. A partial correlation coefficient measures the association between two variables after controlling for or adjusting for the effects of one or more additional variables. Here the partial correlation between x and y while controlling the variable z is given by this relation. Partial correlations have an order associated with them. So, what is the practical significance here? Let me say I am looking on the sales of garments, okay, let me put the sales of woolen garments or woolen clothes. So, sales of the woolen clothes is my y variable, x variable is the price of the garment. The higher would be the price, the lower would be the sale. This is the kind of known thing. Okay. But if I say the temperature or the weather is another variable here. So, when I see the correlation coefficient between or association between the sales of woolen clothes and price while controlling the variable temperature, I would see that the lower temperatures, that is in winters, the sales is high. If I just see the relation between x and y, the price would affect the sales, the price would reduce the sales. But if temperature another variable is there, if it is chilling cold here, if the winter season is at peak and the cold is chilling, the sales would be high irrespective of price. So, this is the use of partial correlation. So, here the continuous dependent variable would be woolen garment sales measured in rupees, continuous independent variable would be the price also measured in rupees, and the single control variable, that is a single continuous independent variable which we are adjusting for, would be the temperature, that is measured in degrees, rupees. This is rupees. And we may believe that there is a relationship between woolen garments sales and prices. Sales go down as prices go up, but it is interesting to know that if this relationship is affected by the temperature, that if the relationship is weaker when we take into account the temperature, since we suspect customers are more willing to buy woolen garment irrespective of price if it is a cold season. Partial correlations have an order associated with them. The order indicates how many variables are being adjusted or controlled. Simple correlation coefficient R has 0 order as it does not control for any additional variables while measuring association between two variables. So, this is a one order correlation, we are controlling one order. So, let us say if I am also having some other variable Z2, if this is Z1, that is availability or market shortage. So, I can put here Z1 and Z2, two variables are controlled. Now, this becomes second order partial correlation. So, this Rxy dot z is a first order partial correlation coefficient as it controls for the effect of one additional variable. The second order partial correlation coefficient controls for the effect of two variables, a third order for the effect of three variables, and so on. A special case when partial correlation is larger than the respective zero order correlation involves a suppressor effect. Suppressor effect means, since we were talking about these two as primary variables, but if Z, temperature, is affecting the cells so much that this partial correlation coefficient is higher, then this is suppressing my independent variable, suppressing my other primary variable price. Temperature is suppressing the price. Next comes the part correlation. Part correlation coefficient represent the correlation between x and y when the linear effects of other independent variables have been removed from x but not from y. The part correlation coefficient Ry x dot z is calculated as follows. That is, the partial correlation coefficient is generally viewed as more important than part correlation coefficient. So, part correlation coefficient is a special case of partial correlation coefficient. So, in partial correlation coefficient, if we say whether there were relation between the graduate and undergraduate grades while we control the IQ, and in part correlation coefficient we can say what is the correlation between the two types of grades controlling the graduate grades for graduate study time. So, this can be one special case, part correlation coefficient can be one special case of partial correlation coefficient. So, with this I would like to stop here. Thank you.